Hi, welcome to the first video that I'm making after my new son has been born. So keep in mind that this could be interrupted at any time by screaming, crying, pooping, peeing, any of the above. So I'll try to make this relatively quick. What we're looking at today is how to alter a graph, transform a graph. Specifically, we're going to look at how to move it left, right, up, down, or how to flip it upside down. There are a lot of other things that can be done to a graph, but those are the three we're going to concentrate on because those are the easiest, and those will apply to what we're doing, or will be doing in class pretty shortly. All right, so the first thing this thing's based on is the idea of a parent function, which is the easiest type of function. For lines, it would simply be the equation of y equals x. For, say, absolute value, would be y equals absolute value of x. There's no extra multiplications going on, no other additions, divisions, subtractions, nothing else. Just something is happening to x, the end. Once you know the shape of that graph, then all of those extra multiplications and additions do common things to each graph. They move it somehow. Okay? Oh, sorry. So let's kind of look at this. So this is a stripped down version of something that's been on my board for just about since the beginning of school. Put it up there for a different class. And if you notice, there's this f for function, which just means we're doing something to the variable x. With lines, it's just x itself. We can be multiplying to it or adding to it, whatever. If we are looking at x squared, then that's what f is. It's the squaring property. Okay, so f is just something we're doing to x. Then we have these modifications. Out here, it could be a positive value or a negative value. That's what plus over minus means, is positive or negative. And what this represents, if you put a negative in front of whatever you're doing to x, it flips the entire graph upside down. So if you have like a U shape opening up, you put a negative in front of your equation, it'll still be the same U shape, except it'll be opening downwards. We'll see an example of that in a couple minutes. The next thing, in the parentheses with x, I cannot stress that enough, it has to be in the parentheses with x. Wherever it's grouped, it's right next to the x. We're subtracting some number. We're going to call it h for now. What that subtraction does is move our graph left or right h places. Now be sure to watch because it's a subtraction. So if it's x minus 2, we're going to move our graph 2 to the right. If it's x plus 2, that's the same thing as x minus a negative 2. So that'll be 2 to the left. So it moves kind of the opposite from how the sign looks because of this minus sign. Last, on the end, just tacked on to the very end of the equation, we're adding a second number. I'm going to call this one k. What that tells us is how far up or down our graph moves from the parent function. Okay? And nothing we're really doing is going to change the shape from the parent. It might flip it upside down. We might move it to the left or right. We might move it up or down, but the basic shape of the graph will remain the same. That's the whole advantage of looking at the graphing from this point of view. Once you know what the original simplest graph looks like, we're just moving it around. Let's kind of look at that. I have a parent function for what you'll learn in a couple chapters is the easiest quadratic, which is x squared. Now, I'm going to show you what this thing looks like. You don't have to know why it comes out the way it does. You don't have to understand any of the properties of that graph. You'll just have to look at what the shape of it is. And then we have these alterations to it, all following the stuff from the previous slide. So if you look, we're subtracting 4 from inside the parentheses. You might want to jot these down on a piece of paper so that when I switch over to the graphs of all these, you can kind of get our predictions down. You can follow along. All right, so we're subtracting 4 inside the parentheses, stupid thing, with x. So minus a 4. That's the h value in with x, and that moves opposite from how it looks. So this is going to wind up moving us 4 to the right. See how this is different? Minus 4 at the end, that should be a prediction. This should be the k value instead. That this is just going to move us exactly 4 steps down. This time it has the negative out front. So that should just look just like x squared, except be upside down. And then the fourth example here applies all 3 of these. So we should be 4 to the right, 4 down, upside down. So let's take a look at that. Here we go. I'm going to set this all up. All right. Okay, that's ready to go. So this is what x squared looks like. This U shape. You'll be very familiar with this shape here in a couple chapters when we start talking about equations that have x squareds in them. But for now, all you just need to know is that's the shape of the thing. So, here's our first example. X minus 4 in the parentheses, and then it's getting the square applied to it. That's our f, is the square. So we said that should be 4 to the right because it'll move opposite from how that sign looks. So that's now going to be in red. And look, it is the exact same shape, except every point on the original parent has been moved 4 to the right to give us now this red U shape. Alrighty, now the next one. This had the minus 4 at the end. Goodness gracious. This has the minus 4 at the end, so that should be moved down 4 from the original parent. Click it on, that's going to be in black. And every point on the original parent function has been moved 4 places down. 1, 2, 3, 4 to give us the black U shape. Alright, just to keep this a little clean, I'm going to go ahead and click those 2 off. The next one had the negative in front, and like we had discussed, that should make the whole graph upside down. So it's going to be in hot pink. So this upward opening U shape, because that negative in front flips upside down, every point is exactly as far below the x-axis as it was originally above the x-axis. So like here's the point 1, 1, so now it's point 1, negative 1 on the opposite graph. And it just opens downwards. Finally, we had looked at an example that did all of them. 4 to the right, 4 down, upside down. That's in green. Oops, I'm going to have to adjust this a little bit. 1, 2, 3, 4 to the right. 1, 2, 3, 4 down. Opens upside down, but the shape of the U is unchanged. It's still the exact same U shape as the original blue graph. It's just been moved around and flipped upside down in this case. All right. Let me kind of center this up again a little bit. Close enough. So going back, I think I'll just do it from here. All right, this is the graph, as it says, of 2 to the x power. It's something called an exponential function because the variable is in the exponent. This is something we'll learn about, study, somewhere around January or February. Maybe March. But regardless, again, you don't have to know why it's this sweeping kind of swoosh shape. Just that it goes flat here, goes up. Again, we're not worried about why any particular graph is any particular shape, just how to move it. So, the next one of these exponentials I have a plus 5 in the exponent with x. It's with x, so that means it's going to move the graph left or right. Plus 5 is the same thing as minus and negative 5, so this should move us which way? 5 to the left. Click it. That's in brown. You can already kind of see it above the box, but there it is. This curve is the same as the kind of orangish tan curve, whatever you want to call it. Just every point on here has been moved 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Can I get up that high? Not quite, but 1, 2, 3, 4. And that one wasn't really on the 2, so it's not quite over the negative 3 yet. But every point has been moved 5 to the left. Compare that with this one, the 8th function. It has plus 1 tacked on to the end. So we have the 2 to the x, the same as our original parent, plus 1 on the end. When you add or subtract a number to the end of the equation, it moves the graph up or down. So this is going to move us up 1 spot. Back to blue. It's a little hard to see, especially over here where the gap narrows, but every point is moved 1 up. Here, it's moved 1 up. It gets so steep it's really hard to tell, but if you go in a straight line, like from, let's see here, 1, 2, 1, 2, 3, 4, right there, and you go straight up to the curve, it is 1 space up. So it gets a little hard because of the steepness here. It looks like it's wider down here than here, but if you go from one point straight up to the next, you'll see that it's the same distance, 1 place up. Let me see if I can kind of rearrange that again, put that back about where it's supposed to be. Oops, piece back here. There we go. Close enough. Alright, I'm going to turn the first 2 off. Actually, I'm going to leave that one on. Alright, so this one has this plus 5 up with x again. So that should still be 5 to the left. But now I have a negative out front. What does the negative do? Check your notes. Flips the graph upside down. So this should look just like the brown graph did, just upside down. That's in red. And sure enough, it's a mirror image. Goodness gracious. Well, you go down there, you go up here. 2 to the x plus 5 is in brown. Negative 2 to the x plus 5 is in red. They're mirror images of each other. One is above the x-axis and goes up. The other starts below the x-axis and goes down. Just how those movement rules, the transformation rules, said they should. Oh, one more of these, I think. get the cursor out of the way. So we have -4 up with the x. So that should be, let's see here, because it's a minus, it should go 4 to the right, correct? And then -7 should be 7 places down. Turn that on. Back to the black. There it is, the exact same curve that we started with the first time. But every point has been moved 7 places straight down and 4 to the right. In fact, I should be able to grab this guy. I should. Maybe not. Maybe it won't let me. Sometimes I can grab these and drag them. I can show you how this one moves right on top of that. But so this point here, 4 to the right, 1, 2, 3, 4, 7 down, 1, 2, 3, 4, 5, 6, 7. And I'm right there on the curve. Hopefully you're starting to see how this works. The specific shape does not matter. Give me a second here to get rid of this thing. The specific shape of the curve does not matter for the purposes we're looking at. We're looking at how the movements work. Let me switch over to this. Now I got a really freaky looking one. This weird thing, it's called secant. It's a trigonomic function. It's what it does is if the x numbers are angles, this tells us I don't really want to get into it too hard. So this is a function you won't even learn until possibly next year. And that's a big maybe. Okay? So you get this weird set of kind of loops. They do not close, however. They go forever up or forever down along the bottom. And why it does that is a whole lot more than we need to get into. Again, for our purposes, you don't need to know why the graph is doing what it does. You'll learn that when we get to the specific functions. All we're looking at is how to move the graphs. So, what does negative in front do? Flips the graph upside down. So this pink going down here flips to this green going up right above it. The pink was in the positive opening up, flips upside down to the negative opening down. Negative goes to positive, positive goes to negative. The pink and the green graphs are mirror images over the x-axis. So click that off. In here, in the parentheses, with the x, I subtract whatever pi divided by 4 is. Could get a decimal, but all you need to know is it's 3.14 divided by 4. 0.8 almost. I'm subtracting that, so I'm going to be moving this to the right by roughly 0.8. That's going to be a tan. Each pink graph, you move it to the right about 0.8, and you get the tan graph. Every point along the curve moves. Doesn't matter how easy or how difficult the function is, that's what that particular value does. So now I have the negative back again, but this time I'm subtracting 2, so I'm going to go ahead and bring that negative graph back. So it should look just like that green function did, except -2. Every point should be pulled down 2 points, or 2 spaces. Sure enough, there's that green graph, which was the pink one upside down. 1, 2. 1, 2. 1, 2. Even down here. 1, 2. Start from there. 1, 2. So the brown graph is just the green graph with everything moved down 2 points. Turn those two off. Move to, see, that's a plus, so move to the left by whatever half of pi is. 1.5 something. And then every point moved up 1. Move to the left about 1.5. Moved up 1. Let's go from here. Move to the left about 1.5. Up 1. On the down here below the axis. Move to the left about 1.5. Up 1. Still just moving the graphs the way that those original directions said to. So let's switch back and end this up real quick. So a negative in front of whatever thing you're dealing with flips the graph upside down. If you subtract a number from x, and it has to be grouped with the x, whether by parentheses or up in the exponents together or whatever you're doing, it has to be with the x. That moves it left or right. And you have to remember, because of that minus sign, it moves it backwards from how it kind of looks. So again, x minus 5 moves us to the right 5. And then if you tack on a plus or minus some number on the end of your equation, after everything else is said and done, that moves you up or down however far k is. And that is, since that's a plus k, that does move the way it's supposed to. A plus 5 would be up 5, and a minus 5 would be down 5. All right, so tomorrow on the homework, or I guess next time we meet, the homework's going to be a handout where I have given you a bunch of those parent functions, and then I give you a specific movement using some combination of these three things, and you need to draw the transformed function. Whatever movements I give you to do, whether it's left, right, up, down, flipping it upside down, you will have to do that to that graph, and that'll be that. Well, that shouldn't take just about one class period, so it shouldn't take too long. All right, and I think that wraps it up, so I will see you in class. Thank you.